Boy, everyone, welcome back to our math class. So for today, we are going to learn a new lesson, and it will be about scatter plot and line graphs. So remember, we have four things to accomplish for this lesson. We are going to finish watching this video, and as you watch the video, remember to complete your guided notes. And also, remember to be attentive as you listen to our video and also understand what you are writing. At the end of the video, you should be confident to answer your independent practices on your worksheet and also on our Alex. So for today's lesson, we'll be focusing on scatter plots and line graphs. To give you an overview, I have these three images. So two images shows scatter plots. So as you can see here, okay, for our scatter plot, our data, our information are represented by dots, okay, and they are scattered, okay, on our graph. While on the other hand, this one is a line graph. It shows trends over time. So what are the difference between the two? We're going to learn that one as we watch this video. So what are goals for our lesson? So remember, our goals will be this. So at the end of the video, you should tell yourself that I can construct and interpret scatter plots, and you should learn how to decide what is the appropriate display to represent bivariate data. So let's make it a great day by learning about these two things. So let's start. So bivariate data consists of two variables or two numerical observations. That's why we call it bi, it means two. On the other hand, scatter plot is a graph that shows relationship between bivariate data. The bivariate data is a graph as ordered pairs on coordinate plane. A scatter plot is very helpful when the bivariate data is not considered as independent or dependent. What does it mean? It means that one variable or value does not necessarily depend on other variable or value. Let's consider this data. So we have here the following table shows the time in hours and distance in miles of seven different hikers. Okay, the time they spent hiking does not depend on how many miles they hike, nor does each individual hiker's time and distance depend on another's time and distance. That's why to represent this data, we use a scatter plot. So take a look at this one. As we construct our scatter plot for this data, we let x represent the number of hours and then y represent the distance hike. Okay, it is very important when you represent information in graph to label your x and y axis. Okay, and we graph data in scatter plot as ordered pairs. So we treat each pair of data as a point. Okay, so for the first one, we have 2.5 and 5. So our x will be 2.5 and our distance y will be 5. For the next, we have 3 and then 6.5. Then we have 4 and 6.75. And then we have 4.25 and 7 and so on and so forth. Okay, so let's graph that one in our coordinate plane. So as you can see here, when we plot points, remember we read the x first before the y. So we have 2.5, it's in between 2 and 3, and then 5 is here. This is our first point. So we have 3 and 6.5, we have 4 and 6.75, we have 4.5 and 7, 5.5 and 8.75, 6 and 9, and 7 and 9.5. So this one is an example of a scatter plot, and that's how you do it. Okay, so now you know how to do scatter plot. Let's do it on our own. So let's have here our first example on your paper. So we are asked to construct a scatter plot of the number of hours students spend practicing for a driving test and their test scores on the driver's test. So as you can see for this data, we are going to represent our x as our number of hours, okay? The number of hours that students spend, okay, in practicing, while our y will be their score, okay, their test scores for our driving tests. Okay, so as you can see here, our number of hours is our x-axis and our y is our test scores. Okay, now let's observe our number of hours. Okay, the smallest number of hours is 6 while the biggest is 12. So we have a range of 6 to 12. So I have used 5 to 13 for our uh, number of hours, okay, and the interval is 1. Okay, well, for our test scores, as you can see, the smallest is 65 and the biggest is 100. Okay, so we have used the range of 65 to 100. Okay. And then we use the interval of 5, okay, for our test score because we cannot use the interval of 1 like 65, 66, 67, and so on because it will be a very long y-axis. Okay. So you also have to decide what range or interval of numbers that you will use to represent your data. You just have to make sure that within that range of numbers, okay, your data will be inside it, like this one. So I have 65 to 100. Okay, all these numbers can be found in that range, and we have used the interval of 5. Okay, so now let's graph our points, okay, on our data in our coordinate plane. So we have 6 and 65 for 6 hours, 65 points. For 7, 70. For 12, we have 100 points. Okay, 8 and 80. 9 and 87. So we don't have an 87 here, but you know it's between 85 and 90. So you can estimate the location of your point. So we have 11 and 93. So it's in between here in the middle. And then we have 10 and 90. 10 and 90. So there you have it. That is a scatter plot for this, okay, data. And you can also infer if we don't have the table and we only have the data, it is very obvious that as the number of hours increases, the test scores increases as well. So it means that if you spend more time studying, the probability of spend more time practicing for the driving test, the probability of getting a score is also higher because you will master the skill as you practice. You will be more confident in taking the test. Okay, let's have another example. So construct a scatter plot of the number of millions of viewers who watch new seasons of a certain television show. Okay, so as you can see here, for this kind of data, it's about a TV show. So we can represent X as our season, okay, and then our Y will be the number of viewers that we have in millions. So let's label our X and Y axis. So our X is our season, is our X, and our Y will be the number of viewers in millions. Okay. So as you can see for our season, we have 1 to 6 season. So we can just write from 1 to 6, 2, 3, 4, 5, 6. And then for our viewers, as you can see here, okay, our smallest number is 22.1 and the biggest is 31.7. So we can have a range of 21 to 32, okay, which will include all our data here. So we use this one since we're not going to start at 0. That one represent all the numbers that we have skipped for y. So we start with 21. So label your y-axis. So we can have this one, this 30, 31, and 32. Okay, and now let's plot our data. So we have for the first season, we have 31.7, it's here. For the second season, we have 26.3. So let's say it's somewhere here. Third season, 25. So 25. Fourth season, 24.7. Fifth season, we have 22.6. Let's say here, 22.6. And then we have sixth season, 22.1. Okay, so what information can you draw about this scatter plot? So as you can see, for the first season, everyone, okay, is excited to watch the video at the TV show. We have 31.7, the highest, but as we move on to new seasons, the number of viewers are decreasing. So maybe the plot was not interesting anymore. That's why the number of our viewers decline for succeeding seasons. Okay, so now we know how to construct our scatter plot, but it is much more important that we know how to interpret them. So we actually have three ways on how to interpret our scatter plots. Okay, let's start with the first way. Okay, you can analyze the shape of the distribution of a scatter plot to investigate patterns of association between the variables. We call this one variable association. Okay, and under this interpretation, we actually have three. So we have positive association. So as you can see, for our positive association, as x increases, our y increases. Looking at this scatter plot, as you can see here, we when our x increases, our value of y increases. So we have an increasing line. Okay, that's why we have a positive association. The second one, we have no association. Looking at this scatter plot, as you can see, our dots are randomly scattered on our coordinate plane. That's why there are no obvious pattern for this kind of association. And lastly, we have a negative association. So as x increases, y decreases. So as you can see here for this point, right, we have a minimal number of x, but our y is the highest point. And as our x increases, it goes down. Okay? It's like having a negative slope for negative association. But for positive association, it's gearing towards the right, so we have a positive slope. That's the first way on how to interpret our scatter plots, variable association. The second way is by the use of our linear or nonlinear association. What does it mean? If the distribution of points on a scatter plot shows a positive or negative association, then the distribution can be classified as linear or nonlinear. We call this one linear association. So if the points are relatively close together, so there is a strong association. Okay, so for linear association, as you can see, the data points lie close to a line, like this one. Okay, so they are very close to a line. Okay, if the points are not relative close together, there is a weak association. Okay, so for nonlinear association, the data points lie in the shape of a curve, like for this one. Okay, they form a curve. Okay, so linear and nonlinear can be classified as strong or weak association. So you have to remember to take a look at how the points are closely to one another. Okay, lastly, we have some other patterns that we can observe for our scatter plots. So for example, for this one, this scatter plot shows a positive nonlinear association, and we have what we call a cluster. A cluster is a collection of points that are close together. Like for example, this one. Okay, this one shows a cluster. So the points are so close to one another. We also have what we call an outlier. It is a point that does not fit the pattern. It's like the odd one out among the dots. Okay, it's separated from the whole group. We call that one outlier. So let's use that one to interpret our data here. So for example, we have here the scatter plot that shows the relationship between the amount of memory in a tablet and its cost. So as you can see here, for our variable association, as the amount of memory increases, the cost increases. Therefore, the scatter plot shows positive association. Okay, as x increases, y increases. For linear association, it appears that the data lie close to a line and the association appears to be linear, so it also appears to be a strong association. Okay, and then for our other patterns, we have a cluster here of points. Okay, so we have 0 to 16 gigabytes of memory cost between $50 and $200. And also on the other hand, we have this one outlier here. Okay, we have your 128 memory gigabyte costs $850. Okay, so these are all the interpretations that we can draw from this scatter plot. Let's try one more. Take a look at this one. Okay, this one is very interesting. Okay, so the scatter plot shows the relationship between a person's height and their most recent math test scores. Do you believe if you are taller, you will have higher scores in math? Let's find out. Okay, so if you will be observing this scatter plot, okay, you will see that there is no association, okay, between the height and the test scores because as you can see, our dots here are randomly spread out, scattered in our coordinate plane. So it doesn't mean that the taller you are, okay, the higher the test score is. Okay, because some students who are not too tall, okay, their scores are also higher. Okay, for linear, okay, this one is considered nonlinear because as you can see, they do not form a line, okay, or a curve as all. Okay, they are just scattered. Okay, and we don't have clusters or outliers. Okay, so remember your height does not affect your test scores. Okay, not only in math but also in other subjects. Remember your test scores are affected by your effort, your dedication and commitment to your studies, right? Okay, and how you much you believe in yourself. Okay, so remember that one. Okay, so whether you're short or tall, okay, put effort, put hard work, okay, and believe in yourself, and you will have good scores in all the things that you are going to do. Okay, so let us try to interpret our scatter plot. Okay, so which is the best interpretation of the scatter plot shown? So we have here a scatter plot that shows about the hot chocolate sales with regards to the temperature and the number of cups. Go over the choices from A to D and try to see which one do you think is the best interpretation of this scatter plot. I'll give you a minute, and I do hope after a minute you will have the same answer as mine. Okay, so for this example, okay, I hope your answer is A. Okay, because as you can see here, as our temperature increases, the number of cups sold decreases. Okay, so the scatter plot shows a negative association. Okay, because it's going down, as you can see here, right? Okay, the association is also linear. Okay, there are no cluster, but there is one outlier. This one is our outlier. Okay, when the temperature was about 26 degrees Fahrenheit, about 10 cups of hot chocolate were sold. Okay, so that is the best interpretation of this scatter plot. Okay, you might be confused with letter B because also for letter B it says here that when the temperature increases, the number of cups sold decreases. However, that is not a positive association because it's going down. Remember, if x when x increases, our y decreases as well. So it's not positive but a negative association. So the correct answer would be A. I hope you're correct with that question. Moving on to the next example. What about this one? Okay. Can you choose which is the best interpretation of the scatter plot shown here? So we have here a scatter plot that shows the number of emails based on the temperature. Okay. So what do you think from A to D? What is the correct answer? Okay, for this question, it's very obvious. As you can see here, our dots are scattered randomly. There's no obvious pattern for our data here. So therefore, the correct answer is letter B. The number of email messages someone receives in a day does not depend on the temperature outside. Okay, so therefore, the scatter plot shows no association. Okay, that is correct interpretation of that one. It doesn't mean if the hot outside, you will receive more email. If it's cold outside, you will receive lesser email. It doesn't work that way. Okay, so therefore, no association. Moving on to our next example. Okay, so what about here for shopping? Okay, so the table shows the data was collected from a random survey for the number of hours different people work in a week and their age. So if a scatter plot was constructed to represent the data, which interpretation would best represent it? Let's go over the choices. Try to see if you will make a scatter plot, which one do you think will be the best interpretation of that data? Okay, so for that one, the correct answer is letter B. So as you can see here, as the age of the person increases, the number of hours they work also increases. Okay, so therefore, the scatter plot shows a positive association and it's also linear. Okay, there is also a cluster of data. As you can see here, if you will observe people under 16 to 22 years, people under people who are 16 to 22 years of age, like for example, these people, okay, they tend to work less than 15 hours. Okay, and we have one outlier, this one, someone who is 25 years old, okay, work for 50 hours in a week. So that is the best interpretation of this data. Letter A is wrong because it says here if a person age increases, the hours decreases. So it doesn't show in our data. The data shows when the age increases, okay, the number of hours worked also increases. So it's letter B, and I hope you are correct. Okay, so we already know how to construct our scatter plot, and we already know how to represent them, okay, to interpret them. So now we're going to dive in with the difference between scatter plots and line graphs. So line graphs and scatter plots, they are both used to display bivariate data, okay, and the relationship between this data. However, line graph is more appropriate to use if our data shows changes over a period of time or there is a trend. Okay, while scatter plots show how the two data sets relate to each other. That's it. Okay, there is no trend. Okay, so let's take a look at for this example. So in this line graph, okay, the growth or the weight of the baby elephant is shown as a trend over several months, and each data point is connected by a line segment. So as you can see here, our growth of our baby Asian elephant, okay, is tracked, okay, and we have a trend from 2 months until 16 months, okay, and as you can see, the weight, the number of pounds of the baby elephant increases, okay, and as you can see here, our dots are connected by line segments. That's why we call this one a line graph. While on the other hand, for our scatter plot, this one shows the weight of the elephants in pounds, okay, and the relationship between the pounds of food the elephant is eating. Okay, each data point is independent of the others, so the data points are not connected by the line segment. The scatter plot does not show a trend as it relates to the passage of time, but rather, this scatter plot shows the relationship between the pounds of food eaten and the weight of the elephant. Okay, that's why it is not represented by a line graph. So that's the difference between a line graph and a scatter plot. Remember, line graph, we have to show trends. Okay, while scatter plot, we just show how two data are related to one another, but there's no trend. Okay, so how do we decide if we use a line graph or a scatter plot? Let's have more example. Okay, so for example, we are talking about the height on the first day of school for 12 years. So we have a trend. We are tracking the height for 12 years. That's why we represent the data on the line graph, okay, because it shows trend over a period of time. So first year, second year, third year, fourth year, until 12 years. Okay, another example, inches of rain over a 3 hour period. Okay, of course, okay, so this one, line graph will be more appropriate because, okay, as the number of hours of rain increases, you know that the inches of rain, the amount of water, will also increase. So it's a trend over a time. However, for the next one, number of people participating in a 5K pace and the temperature, air temperature, we only use a scatter plot because one set of data does not necessarily depend on the other data. Okay, so it doesn't mean if it's too hot, less people will come or more people will come when it's not too hot. Okay, so it doesn't mean that the air temperature affects the number of people. Okay, because that one is about motivation, their interest on participating on this 5K run. So it's only scatter plot. Also, medals won during the Olympics based on the number of athletes participating, we only use scatter plot for that one. It doesn't mean that the number of people joining, okay, will have more number of medals because some events in Olympics, there's only a few people, but we still have the same number of medals. Okay, we have bronze, silver, and gold. Okay, so it doesn't affect if how many people will be participating. So only scatter plot. Okay, to give you more tips, remember, to determine whether to construct a scatter plot or line graph, first, of course, we have to analyze our data. Okay, and then if the data shows a trend over time, we are going to construct a line graph. Okay, and time will be our independent variable, our x-axis. Okay, but if the data show the relationship between two sets of data, only construct a scatter plot. And in these scatter plots, remember that neither set of data is considered the independent or dependent variable. Okay, so let's apply this one in deciding which graph is best to display our data. So we have four examples for this. Let's dive in with our first example. So the table shows the average high temperatures of Louisville, Kentucky. Construct an appropriate display of data, draw a conclusion about the type of relationship the data show, and explain. Okay, so obviously, as you can see, we have our months January to December, and it will give you a hint what kind of data we need to use. Okay, of course, this one talks about a line graph because we are going to show the trend of our temperature within our time of months from January to December. So it's very appropriate to construct our line graph. So let's have this one. Okay, so we're going to do a line graph. And as you can see for our line graph, the months is our x-axis, while our temperature represent our y-axis. Okay, so I have used the interval 30 to 90 because as you can see here, okay, for our temperature, our lowest is 41, okay, and our highest is 87, and we have used the interval of 10 to represent our temperature. Okay, so let's graph it. So January, we have 41, so 41 is somewhere here. We estimate that the location of our points. February is 47, so somewhere here. March is 57, so here. April is 67, it's here. May is 75, so May is 75, it's in the middle. June, we have 83, so June is 83 here. We have July, 87, so let's say it's here. August, 86. Okay, September, 79, so 79 is somewhere here. And then October, 68, so 68 is here. November 56, let's say 56, and then December we have 45. Okay, and remember since this is a line graph, so we have to connect our data points with line segments like this one. So connect them like this. Okay, so as you can see here, okay, so our line graph displays this relationship, our trend of our temperature, right? And we can say that for the months of January to July, okay, our temperature is increasing. And then starting August to December, come winter time, okay, our temperature decreases. Okay, so this information is very important because if you want to visit Louisville, Kentucky on the month of October, you know what kind of clothes you are going to bring, okay, because it's getting cold, so you got to pack your jacket, okay, your sweater, okay. Well, if you will go to Louisville, let's say on the month of June, right, it's a summertime, so it will be hot, so you know what clothes to pack. Okay, so this is the information given by this data. So once again, we use line graph for this one because we show the trend of the temperature, okay, over a period of time from January to December. Okay, let's have our second example. So we have here the table shows the number of minutes it took for a student to run 1 mile over the course of several weeks. So let us construct a display of data and we are going to draw the relationship of the type of data shown and then explain why. Okay, so since we have a course of several weeks, right, we're going to show trend, okay, over the several weeks, okay, so that's why we're going to use a line graph, okay, wherein our x will be the number of weeks and our y will be the number of minutes. Okay, so here our x will be our weeks, so we have 1, 2, 3, 4, 5 weeks. Okay, for our y it will be represented by the number of minutes that the student run for 1 mile. Okay, so we have here from 16 is the highest and 11 is our smallest. So we can go from 10 to 17 for our interval, for our range. And we will have an interval of 1. So remember, we have this one to represent all the numbers that we have skipped. So I have 11, 12, 13, 14, 16, and 17. Okay, so let's plot for the first week. Okay, the student runs 16 minutes for 1 mile. For the second week, we have 14 minutes. For third week, we have 14 minutes. For fourth week, we have 12 minutes. And then for the fifth week, we have 11 minutes. Okay. And based on that one, as you can see here, right, as the number of week increases, right, okay, our time, number of minutes decreases. Okay. So it means that the student is getting faster and faster, okay, as he trained for weeks to run 1 mile. So based on that one, there is a decreasing trend in the number of minutes it took to run 1 mile. Okay, so maybe the student is having a technique already on how to run faster. Okay, because he's covering the same amount of mile, 1 mile, right? But his minutes decreasing. Okay, so he's getting faster. He's building the stamina already. That's why his time is getting lower. Okay, what about for this kind of data? So the table shows the age of a jogger and the number of miles jogged. Construct an appropriate display of data and draw a conclusion about the type of association the data show. Okay, so let's take a minute to look at the numbers. You have here the age of the jogger and the miles jogged. Do you see any trend? Okay, so for this kind of data, there is no trend. Actually, the age of the jogger, okay, does not affect the miles, okay, that was jogged, okay. It doesn't show that the younger you are, the further you can jog, okay, or the older you are, okay, the shorter the distance that you can cover, okay. That is why for this data, we will only use a scatter plot. Okay, so we use a scatter plot for this one because there is no trend being shown. Okay, because if you will observe here, 16 years old, okay, 2 miles. If I am 61, I jog longer, okay, further, it's 2.5, okay. So it doesn't mean that the younger you are, the more distance you can cover, okay. It's so random, okay. So as you can see here, for our scatter plot, we represent the age, okay, for our joggers and our x, and our miles jog will be the y, okay. So let's plot. So if you are 24 years old, you run 2 miles. So let's say 24 is this one, because between 20 and 30, that is 25, so it's less than 25. 16 and 2, 16 years old, 2 miles as well, so it's here, okay. 11 and 3, so 11 and then 3, we have 54 and 3.5. 54 3.5 is somewhere here, okay. We have 38 and 4, so 38 and 4 is somewhere here, okay. 47 and 4.5, 47 and 4.5, to say it's somewhere here in the middle as well. 61 and 2.5, 61 2.5 is here. Okay, 19 and 3. So 19 years old, 3 miles, let's say here. Okay, 30 and 4, 34 miles. And then 57 and 5. So 57 and 5, let's say here. Okay, so if you will observe our scatter plot, there is a weak association, okay, between the age of the jogger and the miles jog. So you can see here, okay, so we have a weak association. So it doesn't mean that our age affects our miles that we have jogged. That's why we only represent this data using scatter plot. There's no trend. So for that, so we have the data show there may be a weak positive association between the age of the jogger and the mouse jog. Okay, so let's move on to our last example. So the table shows temperature in degrees Celsius and the number of bacteria that grows in various petri dishes. Construct an appropriate display of data and draw a conclusion about the type of relationship that data show. Okay, so for this one, okay, since we don't have a trend as well over a period of time, okay, we talk about temperature and the number of bacteria, we will only use a scatter plot to represent this data. Okay, our x will be our temperature and our y will be the number of bacteria that we have. Okay, so we have here from 0 degrees Celsius to 40 degrees Celsius, and for our number of bacteria, since our, okay, we have a interval of 10. So let's try to graph our data. So we have 0, we have 32 number of bacteria. We have 5 and 41. Let's say 41 is here. 5 and 41. This is 5. Okay, we have 10 and 50. 10 and 50 is here. 15, this is 15. And then 59 is somewhere here. 20 and 68. So this is 20 and 68. 25 and 77 is somewhere here. Okay, and then 30 and 86. 30 and 86. Okay, so it's very obvious for this kind of data. Okay, we have a strong positive association because as you can see here, right, as our temperature increases, the number of our bacteria increases as well. Okay, so there is a strong positive association between degrees Celsius and the number of bacteria. It means that the number of degrees Celsius increases, the number of our bacteria increases. Okay, so there you have it. I hope in these four examples you were able to determine when to use line graph and when to use scatter plots. Okay, so what do we do now? So I hope you have finished your guided notes and you have understood the lesson. So as you know that we are going to proceed to our independent practices on our worksheet and our Alex. But remember, if you are still confused, you can go back to the part of the video you find it challenging and you can always come to me and ask me questions. Okay? Before I end this video, I have a question. Before I start the video, I greeted you on a way that I greet my Filipino students. Okay? If you are listening attentively, tell me how do we say good morning, okay, in Filipino. And if you will tell me the correct answer, I will give you a prize. Okay, thank you very much and hope to see you for the next lesson.